Hi, hello and Assalamualaikum. We are from Computer Science course which is CS110. We will be presenting a topic from Calculus 1 or MAT 183. The topic is applications of differentiation. There are 4 subtopics for this topic, which is related rate analysis function, applied maximum and minimum problems, and the last is Rolle's theorem and mean value theorem for differentiation. Our group choose applied maximum and minimum problems because for us this subtopic is interesting. Before that, I want to introduce my group mates and I. First is Nur Isha Ayuni binti Saleh and her metric ID is 2023463606. Second member of our group is Muhammad Amar bin Mat Nasli and his student ID is 2023602138. And the last is me. My name is Muhammad Anash Imran bin Nasruddin and my student ID is 2023457974. And now I will hand over the presentation to Amma.
Applied maximum and minimum problem is about the process of finding maximum or minimum values is called optimization. Many application problems in calculus involve function to find maximum or minimum values. So why we use applied maximum and minimum problem in calculus? So the first is to increase the understanding about application of differentiation. And next, to understand applied maximum and minimum problems. Last but not least, to be able to solve the question by using the suitable formula. And this is how the way we used to apply maximum and minimum problems. So the first one, identify all given quantities and quantities to be determined. Define your variables if possible. Make a sketch. Next, determine the restriction on the variables. And then, find a secondary equation that relates to the problem. Write a primary function for the quantity that is to be maximized or minimized. Then, use the primary and secondary equation to create a function where you plug the secondary function into the primary function. Last but not least, take the derivative of the function, set it equal to 0, solve the equation to find the critical points, and determine where the relative maximum or minimum is.
So now, let's dive into the heart of our presentation. It is the problem statement and solution part. Stay focused because this is where it gets really exciting. So, we can see that a closed cylindrical container of radius r cm and height cm is to be made to hold 600 cm³ of liquid. Shown that the surface area of the container is 2 pi r square plus 1200 over r. We need to find the values of r that minimize the total surface area of the container. Give your answer correct to 2 decimal points. And then, hence find the minimum surface of area of the container. For question A, we already know that the area is equals to 2 pi r square plus 1200 over r, which is it will return to 2 pi r square plus 1200 r to the power of -1. We need to find the derivative of the function. So, dA over dr is equals to 4 pi r minus 1200 r to the power of -2. This also can be written as 4 pi r minus 1200 over r square. So, in order to get the value of r, we need to let the dA over dr is equals to 0. So, 4 pi r minus 1200 over r square equals to 0. So, 4 pi r equals to 1200 over r square. And then, we need to move r square to the left. So, it will become 4 pi r to the power of 3 equals to 1200. And then, r equals to square root of 1200 over 4 pi. And we will get the answer of r, which is 4.57 centimeter. For the last step, we need to do the second derivative test, which is d square a over dr square equals to 4 pi plus 2400 over r power of 3. So we need to substitute the value of r in the equation, which is when r equals to 4.57 centimeter. So d square a over d square equals to 5 plus 2400 over 4.57 power of 3. So we will get the answer is 37 over 71, and as we know that 37.71 is greater than 0, so the value of r is equal to 4.57 centimeter, which is a minimum value. So for the conclusion part, we can see successfully tackling apply maximum and minimum problems depends on identifying the appropriate formula and accurately performing both the first and second derivative. This ensures that we can lead to a solid answer, which is achieving the maximum and minimum cost effectively. Last but not least, mastering this technique not only enhances our analytical skills but also equips us with valuable tools to address complex challenges effectively. Thank you all for joining us in this exploration of apply maximum and minimum problems. We truly appreciate your attention and interest. A special thank you to our lecturer, Madam Nurelini binti Jauhari, for her invaluable teaching in MAT 183, which has enabled us to create this video. We apologize for any deficiencies throughout the presentation. Thanks again for watching. Stay curious and keep exploring.